மாணவர்கள் அனைவருக்கும் வணக்கம். ஆர்டிஃபிஷியல் வேரியபிள் டெக்னிக். The Beckham method. The Beckham method involves few steps for solving linear programming problem. Step 1. Exposing the linear programming problem in the standard form by introducing slack and or surplus variables if necessary. Step 2. Introducing the non-negative artificial variables R1, R2 and so on to the left-hand side of all constraints of greater than or equal or negative type. The purpose of introducing artificial variable is just to obtain an initial basic feasible solution. However, addition of these artificial variables cause violation of the corresponding constraints. Therefore, we would like to get rid of these variables and would not allow them to appear in the final solution. To achieve this, we assign a very large penalty minus m for maximization problems and plus m for minimization problems as the coefficient of the artificial variables in the objective function. Step 3. Solve the linear programming problem by simplex method. While making iterations using simplex method, one of the following three cases may arise. First, if no artificial variable remain in the basis and the optimality condition is satisfied, then the current solution is an optimal basic feasible solution. If at least one artificial variable appears in the basis at 0 level with 0 value of xb column and the optimality condition is satisfied, then the current solution is an optimal basic feasible solution, though it may be degenerated. Step 3. If at least one artificial variable appears in the basis at non-zero level with the positive value of xb column and the optimality conditions is satisfied, then the optimal original problem has no feasible solution. The solution satisfies the constraints but does not optimize the objective function since it contains a very large penalty m and is called pseudo-optimal solution. While applying simplex method, whenever an artificial variable happens to leave the basis, we drop that artificial variable and omit all the entries corresponding to its column from the simplex table. Example problem. Solve the following LPP by simplex method. Maximize Ez equal to 3x1 plus 2x2 subject to the constraints 2x1 plus x2 less than or equal to 2, 3x1 plus 4x2 greater than or equal to 12 and x1 x2 greater than or equal to 0. This is the problem involving mixed inequalities. Here which is less than or equal, this is greater than or equal. So the first constraint needs slack variable for converting into equation. The second condition needs the surplus variable for converting into the inequality into the equation. So we need two variables, slack and surplus variable respectively. By introducing the non-negative slack variable S1 and surplus variable S2, the standard form of the LPP becomes maximize Z equal to 3x1 plus 2x2 plus 0x1 plus 0s2. These are shadow costs. The slack and surplus variable appears in the objective function with the shadow costs. 2x1 plus x2 plus s1 plus 0s2 equal to 2, 3x1 plus 4x2 plus 0s1 minus s2 equal to 12, x1 x2 s1 s2 greater than or equal to 0. but this will not yield a basic feasible solution. To get the basic feasible solution, add the artificial variable R1 to the left hand side of the constraint equation, which does not possess the slack variable, and assign minus m to artificial variable in the objective function. The LPP becomes, we need artificial variable whenever we appear the surplus variable. Whenever appear the surplus variable, we must add the artificial variable for the corresponding constraints. So maximize z equal to 3x1 plus 2x2 plus 0s1 plus 0s2 minus m. This is the penalty. Minus m for maximization problem plus m for minimization problem appear in the objective function. Appear in the objective function or the artificial variables. So S1 is the slack variable for the first constraint, and S2 is the surplus variable for the second constraint, since the constraint is appear in the problem greater than or equal to constraint. Whenever appear the surplus variable, we must add the artificial variable. So R1 need for the second constraint because of S2 is surplus variable. The initial basic feasible solution is given by S1 equal to 2, R1 equal to 12 are called the basic solution, and x1, x2, s2 equal to 0 are non-basic variables. We setting out 3 variables equal to 0 for attain the basic feasible solution. This is the initial iteration table. We arrange the coefficient of the constraints as here, and CB column denote the cost vector, YB column represent the variable appears artificial, basic or non-basic variables in the YB column. These are the value for the artificial or basic or non-basic variables. Here we identify the utmost negative minus 4m minus 2. So x2 enter the basis, s1 leave from the basis, since the ratio of 2 is minimum among the ratios. We find out the ratio for the corresponding two columns. 2 is the minimum ratio, so we identify the variable s1 leave from the basis. Since there are some zj minus cj less than 0, the current basic feasible solution is not optimal. The non-basic variable x2 entered into the basis, and the basic variable s2 leave from the basis. First iteration table. Again, 1 is the leading element, which is already 1. So we write the pivots row without change from the first table, and we replace s1 by x2 because of s1 leave from the basis. R1, the new pivot row is here. Here identify the table as all the, this is called the net evaluation. All the values in the net evaluation are greater than or equal to 0. So we attain the optimal solution. Since all zj minus cj greater than or equal to 0 and an artificial variable r1 appears in the basis at non-zero level, the given LPP does not possess any feasible solution, but the LPP possesses a pseudo-optimal solution. இந்த அளவிலே இந்த வகுப்பை நிறைவு செய்து கொண்டு அடுத்த வகுப்பில் சந்திப்போம். வணக்கம்.